In this video, we're going to talk about using trig ratios to find unknown sides of right triangles. Now, we are moving into trigonometry, and the word trigonometry is from the Greek language, and it means triangle measurement. So, if you're given a triangle, in this case we're going to be working specifically with right triangles, we can find unknown sides that make up the triangle or unknown angles within the triangle using pieces of trigonometry, the math of trigonometry. And in this video, we're going to be talking specifically also about ratios. Ratios will help us find unknown side lengths, or just ratios of specific side lengths in reference to a given angle. And the famous acronym of trig ratios for right triangles, and again, before we get there, right triangles have a right angle in there, and the right angle is always specified by that little square you see in the bottom left-hand side. And so if you ever see a triangle with that square within it, that means that that angle is 90 degrees, a right angle, and then that triangle is a right triangle. So the famous acronym that goes with right triangle trig ratios is SOHCAHTOA. And I'm going to rewrite it like this as well. This is sometimes helpful. SOHCAHTOA, like that. All right, because the S, the C, and the T within this acronym stand for the three trig functions, sine, cosine, and tangent, respectively. And then the ratios that exist within each trig function exist with the O and the H, the A and the H, or the O and the A. They stand for opposite over hypotenuse. So if we're dealing with the sine of a given angle, sine stands for, sine goes with the opposite over the hypotenuse. That's what SO is of the acronym. Then cosine, or Ka within the acronym, is adjacent over hypotenuse. And then tangent, the trig function tangent, is TOA in the acronym, and it stands for opposite over adjacent. And so I just rewrote it like this in green because it helps to visualize the sine function S stands for the opposite over the hypotenuse, or O over H, that type of thing. Now, this is always in reference to a specific angle. So if you notice this triangle on the left here, it is all these pieces are in reference to angle A. So the sine of angle A is opposite over hypotenuse, and we labeled it accordingly. The opposite side jumps over the triangle, so it's the furthest one away from the given angle. That's one way I like to think of it, the jumping over the triangle, far away from it. The hypotenuse is always the same, no matter what angle is in question. The hypotenuse is always the longest side of the right triangle, and it exists across from the right angle. Think hypotenuse, super long word. It's the longest side of the triangle. And then finally, the adjacent is the closest side to the angle in question. It's the side touching the angle in question, or adjacent also means like next door or right next to it. And so it's the side that makes up the angle in question that's not the hypotenuse. So it'll always be connected with the hypotenuse, but it's never going to obviously be that hypotenuse. So that's all in reference to angle A. If this switched over and we wanted to find ratios of angle B, then the opposite and the adjacent would switch locations because we switched angles. And we're going to talk about that in just a minute. But that is SOHCAHTOA. Please familiarize yourself with that, and those are the ratios in reference to a given angle of sine, cosine, and tangent. Now, if I'm going to put that into action in example 1, it says find the sine, cosine, and tangent of the indicated angle. I'm going to do angle D, and then I'm going to ask you to do angle E. So angle D, I want to find the sine of D, the cosine of D, and the tangent of D. Alright? Then, if I'm given a triangle over here, I am, it has angles D, E, and F. I'm going to circle D and label my triangle appropriate to the reference to that angle of D. And so opposite of D, again, if I'm labeling a triangle, and I would like you guys to label your triangles too as you're working through this process. If I'm labeling, it's always in reference to the angle in question, and there's three choices: opposite, adjacent, and hypotenuse. Alright? So first thing first, the hypotenuse is always the longest side across from the right angle. So this is the hypotenuse. So in this case, my hypotenuse is 50. Now, opposite of D, I have to jump over the triangle. Opposite is the side that never touches the angle, is furthest away from the angle. In this case, the opposite side exists over here, and it's 14. And then finally, adjacent is the side right next door to the angle in question, touching the angle in question, but not the hypotenuse. In this case, it's down here, and it's 48. So I have labeled my triangle correctly in reference to angle D. Now let's talk about the trig ratios. Sine, if I go back to SOHCAHTOA, sine stands for opposite over hypotenuse. I'm looking over here, all right? So the opposite, in this case, is 14 over the hypotenuse of 50. And these are both numbers, and they're both even numbers, so I can reduce them or divide them both by 2. So my reduced fraction is 7 over 25. And I would like you to reduce your fractions. Cosine, then, if I go to SOHCAHTOA, is ka, and it's adjacent over hypotenuse. All right? So the adjacent side is 48. The hypotenuse is 50. And that reduces to 24 over 25. And then finally, tangent. If I go back to SOHCAHTOA, tangent is toa, and it's opposite over adjacent. So the opposite is 14, the adjacent is 48. And that reduces to 7 over 24. Alright, so I have found my trig ratios of angle D. Now I'm going to ask you to find the trig ratios of angle E. Alright? And I'm going to help you label the triangle appropriately. If we're going to go now to angle E, I need to change my opposite and my adjacent. Now, angle E, the opposite side of angle E, is the bottom piece, the furthest one away that's not touching angle E. So this becomes the opposite of angle E. And then, again, the hypotenuse never changes, but the adjacent side now is this piece right here that's touching angle E. That becomes the adjacent right here. So they've switched locations because we switched angles. So, pause the video, go ahead and tell me the sine, cosine, and tangent ratios for angle E. At this point you should have paused the video and found the trig ratios in reference to angle E. I have sine of E is 24 over 25, cosine of E is 7 over 25, and the tangent of E is 24 over 7. Alright, so hopefully your work looks like that. If you didn't get those ratios to be correct, please raise your hand and I will come check your work. Now this ends this video. I'm going to break this up into 2 videos. In the next video, I'm going to do example 2, which calls upon a little bit more knowledge of the Pythagorean theorem, because if you notice, some of the sides are unknown. And let me adjust this actually. I'm going to make this be 6. Now, in this case, we're going to have to use the Pythagorean theorem to find the unknown side B before we can go about finding the trig ratios. So please make A have a length of 6. And that is it for this video. Thank you very much.